Welcome back to the shop during a new project. First of all, taking photos of a black bicycle is never easy. Taking videos is even harder. This is my slate. It's a Cannondale slate. As you can see, it's got the Cannondale front fork, which is telescopic. And it's only on the left side, that's why they call it lefty. And I just had myself measured to the bike to make sure that the settings are right. The seat height, the handlebar position. I've been trying to do this for 15 years but never really had the time. And what we found out that I really need an XL size bike, so extra large. I've been riding a large size, and for my 6 foot I would really need a larger one. So I'm not in a position to get a different bike, a larger frame right now, especially because getting these slate bikes, it's really hard. These became a popular phenomenon. Cannondale doesn't make them anymore, and so what the technician was trying to do is adjust the seat height and then see my knee position relative to the pedals. And he also tried to move the handlebar forward, and he has a universal jig that on other bikes he can attach to the stem here, but it didn't fit this one because it's got this maybe 1.25" stem post, or I think they call it a steerer tube. So what he told me is to get a different stem. So this stem is 100 millimeters. This distance from this axis to this axis 100 millimeters. It's got a 5-degree rise, and initially it was pointing down, and he flipped it and pointed it up, which puts me back on a saddle. And so he recommended to use a 120 long and 20-degree rise. And what I'm going to do is disassemble this piece and then 3D scan it and design a new stem, 3D print it, probably several different versions, and then assemble it to the bike and see which one fits the best. Now the problem is that Cannondale doesn't have these parts anymore, and I also contacted Cannondale specialists. They are in Utah. They usually have all the parts that you need, and they didn't have it this time, so I'm gonna make one. So I removed the handlebar, and the stem just pops off like that. There you have it, 110 millimeter, 5-degree stem. What do you got?
We got disappearing spray for scanning.
What does it do?
It will make it easier to scan, but after 4 hours the spray will disappear off the part, just vaporize.
So I'm guessing the scanner doesn't like shiny objects?
No, it doesn't like shiny, or it doesn't like black objects, so sometimes we coat it with some spray and it will make it easier for data acquisition.
Okay, let's hit it, man. Operation Unshiny. What we did is we laid the part down on a turntable. Looks like this turntable is perfect size for this part. And we are scanning it from a different viewpoint. And software is automatically stitching it together. So what we got here is a composite of several scans. You can see the lines here between the various scans. We got our own watertight geometry. You can see some of the internal features are missing, but we can safely assume that this is a machine from a billet, and those internal surfaces are just an extrusion from the base feature. The internal cut, the data looks good enough to recreate it. with a parametric tool like Creo. Okay, so the dog and pony show just keeps going on. That's the cap for the stem, and we already applied the hair lac, the hairspray, and it is running now and scanning the part. Okay, so we have the cap, the stem cap, scanned now. Can you show the other side? Looks like there's good data. It's not watertight yet. But we're going to be working on it. Here's the 3D scan imported into Creo. I established some basic datums, and now I can conduct measurements. You can see the axis to axis distance is 100.05 millimeters, so it's 50 microns off. That's about the thickness of a human hair, and the angle is 5.13 degrees. So we can conclude that the part in the 3D scan are fairly accurate. Next, I created the basic shape in Creo, and this is fully parametric. You can see it only has a handful of features shown here, maybe about 20 features, and the agreement between the 3D scan and the parametric model is fairly good, both on the inside and on the outside. As I was working on this, I still didn't know what exact size I'm going to need to replace this 100mm stem. I decided to create a stem fitting jig. Again, the specialist who was doing my bike fitting had a universal stem fitting jig, but it didn't fit the Cannondale's 1.5 inch steerer tube. Here's the 3D model of the stem fitting jig I came up with. It has 6 3D printed parts and some metric fasteners. The handlebar offset can be adjusted between 80 and 130 millimeters, while the angle can be adjusted between 0 and 20 degrees in 5-degree increments. To raise the jig to a different angle, this bolt has to be removed and positioned into a different hole on the steerer bracket. This is a fully parametric model. I can adjust the part's position by simple double clicking on this spine or curve, and as you can see right now it's set to 80 millimeters and 15 degrees. If I change that to 125 for example and 0 degrees and regenerate, the software is going to rearrange the parts automatically. So I can go and choose 20 degrees for example, regenerate, and you can see the software is going to rearrange it. Now let's go and print this sucker. Looks like we still got this green filament. That's an old spool. There's not much left on it. And here's the part. Here's the piece with the support removed. Did just a little bit of filing, so there's the support. Just pops out. And then here I just did a little filing. Probably do a little bit more cleanup later. Let's see if it fits. So this is the handlebar for the Cannondale. You can see it just pops in like that and stays put. These are the parts that are already completed, and it fits in nicely and it slides along just like it should. There's not much filament left on this spool. I guess I got lucky. Many times you just run out of filament, you don't even know about it. This spool is probably 5-6 years old, so it's gone. No more green filament, only red.
Wah, 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 wah.
Alright, here's the stem fitter mounted to the bike. There's about 7 hours of CAD design in it and about 20 hours of 3D printing. It's pretty flimsy. I wouldn't ride it, especially because of these weight savers that I put here. If anybody ever gonna need this beside me and I'm gonna upload the design, I'll probably take these out. There's a high bending torsional load in this area. You can see how it's wobbling. These screws are not tightened right now. Sorry, I lost the audio on this clip, so I'll try to narrate it now. These are the new and old stems side by side. Instead of firing up the machinery industrial complex, I went to Flea Bay and scored this 120mm 5-degree stem for $35. You can see the difference between the stem mounting bolts. The old one, which is 100mm long, has an M5 screws and it requires 5 Newton meters of torque. The new one that is 120mm long and has M6 screws, and it has to be tightened to 8 Newton meters. This is due to the increased moment arm. So I laid it out because why not? So these are 2 spacers here. They are 5mm each. I thought it's 200 thou, which would be 508, doesn't matter. So they are only 5mm. These are standard spacers that came with the bike. And then there's one here that's supposed to be 100 thou or 2.54, but it measures 2.6. And if you look, this is where the old stem was, so it was 100mm 5-degree, and this is angled. Okay, so the stem is pointing up at this location, and I looked at 120 degrees and 120mm and 10 degrees, and the end would be here, the red dot, and I'm gonna have a 120 and 5 degree, which ends up being here at the green dot, so that's a 9mm drop. Little hiccup here. Look at that, the screw is completely tightened, so there's no gap left, and it's still not locking on. And you can see it's moving up and down. So if I measure this, 38, 36, 38, 32, so that would correspond to 1.5 inches. So this is the original stem, and it measures at 38-32. So just 20 microns above the size of the tube, the steerer tube. And then here's the new stem that I bought. That appears to be Cannondale, so it measures 39-69. Half an hour later, here's the prefabricated MLI. Seems to be a good fit. So there's a new stem installed. Tighten up the bolts to torque. There's the shim. You can't really see it unless you know what to look for. I went out for a quick ride and it looks good. Thanks again for joining in. Hopefully you learned something, and come back next time.